when the solar maximum. So that's actually affect how we launch satellite with satellite, because when the atmospheres expand, you got more density out there, and you create more drag to the satellite. That's one of the things that happened to the Starlink that I didn't go into detail. That's one of the things happening. They actually the atmospheres expand and then create more drag, and they just launch in a lower orbit because the 300 kilometer, and they just brought it right down. Yes, absolutely.
Why is the solar probe coated in black rather than white?
We gone through a lot of study trying to actually, one of the version was white, but not only we have to look at the visible, we also look at the UV. Actually, when you get close to the sun, the UV was really intense, and it actually changed the material. We launched it at black, but if you have somebody to look at it, what it is right now, I think it's going to change color. So black works out to be the best because we have to look at the emissivity of the material, and black works out the best. I didn't go into much detail, but not just the heat, there's like I said, the UV and the electrons environment. It's a lot of electron out there. It changed the property of, and we find out the black material is actually the one that survive. That was actually a good question. I'll may go into that. The other thing that's I didn't talk about, solar probe actually discovered there's a lot of dust around it close to the sun. When I say dust, it's not that what we're getting in the Sahara later on. This is a micron style, 10 to the minus 6. And it constantly bombard the spacecraft, TPS. We actually have the camera that I show. We saw dust, basically dust hitting the TPS and create a plasma. And you can measure that. One of the instruments actually lost some aperture because of those dust are hitting the instruments. We're lucky the spacecraft still survived. That's one of the things that we actually keeping our finger crossed.
And then last, little bit of fun question. How did the early astronomers not go blind? How did they look at the sunspots? What were they doing?
I couldn't tell you those actually look at survive to tell you that, but they were a lot smarter than we are. First of all, I can't say some other people didn't look at the sky, but they're all projections like you all do. These days, they just project it up to the ground to look at. Don't ever look at the sun directly, ever, even in eclipse.
All right, let's thank our speaker once again. There were a couple questions that didn't get asked. Dr. Ho, if you're available, perhaps during the break, could discuss some of those questions. And so we're going to have a 10-ish minute break. We'll come back at 7:45 for Astronomy in the News. Thank you, everybody.
All right, folks, we're going to get ready to settle back in for the second half of our program. Let me ask Oscar. Oh, damn, darn it. I was going to ask him where he got this video from. It was? Where'd you get this video from again? Where'd you take this? Stone Oak. So there you go. So Stone Oak. Now we can, here on the television, I'll get out of the way. Here you go. Here's the full video. Yes. Yeah. Right. Yep. Yeah, so there's the sun going behind the dust. Very, very cool. All right, well, thank you for sending it. And then, of course, yeah, if anybody has any other interesting sky photos, I updated that. It's not night sky anymore. It's interesting sky photos because we'll take anything. Samuel Hart Helio at gmail.com. No UFOs, of course, because we believe we need to hide them. It's our job as scientists. Supposedly, we have to hide. I don't know. It's yeah. Oh, where's my? There it is. All right. We proceed with Astro Jazz doing Astro News. So without further ado, Astro Jazz.
Hello. Hi, everyone. I know I wasn't here last month, so I missed all of you. I hope you missed me too. We are back to our regularly scheduled news coverage. I'm going to try to do this with my hands. All right, so our title today, New Emotional Support Astronauts Dropped. Yeah, what? What? Yeah. Okay. Yeah. Okay, we good right now. Okay, so what can we see in July? So this is actually one of the best times to look at the Milky Way. Mid-July. Oh, go back. Mid-July near the new moon is one of the best times to look for the Milky Way. So if you drive anywhere out of San Antonio, literally in any direction, away from the city, go look for the Milky Way. Preferably where? West, yes, preferably west. All right, so that is a huge thing to look for this month. You can also look south. You have Scorpius on the bottom. And we have, yes, you point to that. And then we have the bright red star Antares. And we have Sagittarius, the teapot nearby, which points toward the center of the Milky Way. And then we also have the summer triangle, which rises in the east. We have the bright stars Vega, Deneb, and Altair, which they are up there. Yeah. And the moon can also be spotted near Venus after sunset. So get some photos. I know recently we had some planets with the moon that everybody took photos of. And then later this month, we're going to have the full buck moon and then the southern delta Aquariid meteor shower. So if you want to see the meteor shower, definitely look late night and pre-dawn because the moon is going to wash out the fainter meteors. That is something to pay attention to. Okay, I'm getting better at this part. All right, so biggest news last month. I'm sure a lot of you watched the live stream. The Artemis 3 crew was announced. So we have the 4 astronauts that are going to fly aboard the Artemis 3 mission: Randy Bresnik, Luca Parmitano, Andre Douglas, and Frank Rubio, pictured here. So this was scheduled to be the initial moon landing mission, but because of kind of the shifts in the Artemis program, it is now just scheduled to 2027 as an Earth orbit test flight focused on Orion and commercial lunar landing operations. So basically, going to the moon, a major goal is going to be rendezvous and docking between Orion and commercial lunar lander test versions from companies like Blue Origin and SpaceX. So the mission is still very important because it's going to test key steps that are needed before the astronauts eventually do return to the moon to set foot on the lunar surface with Artemis 4. I will say I hope there's a woman on Artemis 4. Multiple women, that would be nice. But the mission is still very important, and it's a major step in NASA's goal of returning people to the moon and hopefully going to Mars. Because even though this isn't the lunar landing mission anymore, it's still testing the meetup part in space that the future missions are going to depend on. So it's still very key mission in the Artemis program. And I'm excited. Thank you. Okay, this is, I'm sad it's kind of washed out in the slide, but the image is very, very pretty. And I didn't see enough people talking about it, but this image has 60 million stars in it, if you would believe, yes. So the ESA's Euclid Space Telescope captured what they say is the most detailed image of the heart of the Milky Way. It took the image in only 26 hours, which is insane for how big of a region of the sky this is. It's actually a mosaic of 9 paintings from Euclid's visible light camera, and it contains more than 60 million stars, including nebulae and star clusters. This is a 6 gigapixel view, and the largest high-resolution visible light photo ever made of the Milky Way's center. So this image is really useful. It's going to be useful for studying exoplanets through gravitational lensing, which I will talk about the Roman Space Telescope, is going to do later on in the future. And it also shows Euclid's ability to map huge detailed areas of the sky. So I know it's an ESA telescope, but we don't talk about it enough. Euclid is a very powerful telescope. I think this image, again, it is not being done justice on this projection, but please do look it up. It does have 60 million stars in it. I counted. So if you zoom in, though, this is a zoomed in image. So it may look like glitter, but it's not glitter. It's a bunch of stars from that same image. Thank you. Okay, so very exciting news for the Vera C. Rubin Observatory. It has officially begun its 10-year sky survey. So the Rubin Observatory officially began its legacy survey of space and time. So basically, over 10 years, it's going to repeatedly image the southern sky to create kind of a movie of the changing universe. And Rubin, this is really important because Rubin has the largest digital camera ever built for astronomy at about 3,200 megapixels. Each image is going to cover an area of the sky about as large as 45 full moons, which is why it's going to be able to survey the sky so quickly. And it's going to collect about 10 terabytes of data each night and produce up to 7 million alerts for things changing in the sky. So it's going to help us study asteroids, supernovae, galaxies, dark matter, and dark energy. And a big part is not just the image quality and how much imagery we're going to get. It's going to revisit the same areas of the sky repeatedly, which is going to make time domain astronomy way more powerful. 800 times what? Oh. Okay, 800 times. It's going to see each part of the sky 800 times in the 10 years. Thank you, Aaron. And so this is huge. It's one of the biggest astronomy survey projects of the decade, and I think this is going to greatly advance so many things in astronomy. I can't even talk about it. So I am looking forward to the next decade with Rubin. But something else to look forward to is the Nancy Grace Roman Space Telescope has finally arrived at Kennedy Space Center. So this is a photo of it arriving over there. So it has arrived for the final launch preparations. And fun fact, it has actually arrived 8 months ahead of schedule. So that's, 8 months ahead. That's pretty exciting. We're doing something ahead of schedule. That is rare for astronomy. That we're actually out of a schedule. Yeah. So Roman, it is NASA's next major space telescope mission designed for wide field views of the universe. Currently, let's hope this doesn't change, its launch is targeted for no earlier than August 30th of this year, so look forward for that. And so what is it going to study? It's going to observe in the near infrared, and it's going to study dark energy, exoplanets, galaxies, and the structure of the universe. And fun fact, the observations for the first cycle of the mission have already been selected, so it's going to get right going into the science. This is really exciting stuff. And if you didn't know, it is named after Nancy Grace Roman, who is often called the mother of Hubble because of her major role in making space telescopes happen. So if you love Hubble, if you love James Webb, you're going to have a new one to love. And we do have some friends that are going to be working with this telescope, so that's exciting. All right, a more fun thing, Perseverance has officially completed a marathon on Mars. So a marathon, 26.2 miles, it reached that last month. I will say it's kind of sad that a robot completed a marathon before me, but it's okay. I guess it just motivates me to do one myself. It actually reached this marathon on June 14th, which was about 5 years and 4 months of driving. So this image I wanted to include, the Mars Reconnaissance Orbiter actually captured a picture of Perseverance near the milestone location. So this was like real time, like this was a recent image. So that tiny little dot that is being circled with the yellow circle is Perseverance. And I don't know, I kind of find it funny when like spacecraft up top are taking pictures of spacecraft on the surface of planets. I think it's really cute, so I really like that. But I don't know, it's funny. So we, humans, we can run marathons in a few hours, but a rover took a few years to do it. But I will say it did it on another planet, so it did kind of reach a milestone. You kind of, I guess this is the first marathon completed on another planet, so. All right, and last but not least, we have some new images. We have the Cigar Galaxy M82, which was imaged using Hubble and Webb data. I have some fun facts now, so I'm going to include my fun facts. It's a starburst galaxy. It's forming stars much faster than a normal galaxy like the Milky Way, and Webb has an infrared view, so it can reveal millions of stars and everything cutting through the dust, which are harder to see in visible light. And then we have the Orion Molecular Cloud from Webb. This is a star-forming region in the Orion Nebula. Webb has captured actually different stages of star formation in this one kind of image. We have stellar embryos, protoplanetary disks, and young stars. It's 1,280 light years away, so it's basically a stellar nursery. So in this image, you can see stars being born. And then we have this very bright image. This is the chandelier cluster. Take a guess why it's called the chandelier cluster. It is a dense ancient ball of stars located 27,000 light years away in Sagittarius. Yeah, this is like a fossil record because it contains very, very old stars. And last but not least, we have a galaxy cluster. I'm not going to say the name, from Hubble. It is a huge group of galaxies bound together by gravity. Hubble observed it in visible and infrared. And you can notice the gravitational lensing, which galaxy clusters can act like that, which they bend and magnify light from even more distant galaxies behind them. So it's kind of like a magnifying glass. So some images. And now I will not forget to do the announcements. Okay, so SAAA, we have every Wednesday at sunset observing. And then July 10th, I wanted to give a shout out. I'm gonna be giving a talk at SAAA about Europa Clipper, which is the mission I work on. I'm going to be talking about the importance of the mission and what kind of things we're hoping to find. So come see it at Scobie at 7 o'clock on the 10th. And then we have multiple different star parties on the 11th, the 18th, and then the 25th is the Guadalupe River State Park outreach. And then Scobie Planetarium every Friday, except for July 2nd and 3rd. Thank you.
this. We can be coordinated sometimes. All right, I have the distinct pleasure of introducing our very own Dr. Michael Velez for what will be his last talk here at AOT, because he will be leaving us in September. He did get a job, so we'll be very happy about him for that. All right. Dr. Michael Velez was born and raised in sunny South Florida, which explains his love of warm weather and outdoor recreation. He is currently a postdoctoral research at the Southwest Research Institute. He received his Bachelor's of Arts in Physics with a concentration in astronomy from Cornell University in 2019, because he's Mr. Fancy Pants. He then received his PhD in Physics from the University of Texas at San Antonio in 2025, working in the Joint Graduate Program in Space Physics and Instrumentation with the Southwest Research Institute. His dissertation topics included developing a stellar catalog for ultraviolet research, analyzing optical emissions at Europa using the Hubble Space Telescope and HST far ultraviolet data to analyze the surface of Europa. Michael has also served as a graduate and postdoctoral affiliate on the Europa Clipper and JUICE ultraviolet spectrographs. His current research includes analyzing the surface of Io with HST, as well as assisting the in-flight calibrations of Europa and JUICE UVS. He's also spent some time at the Planetary Science Summer School, and he'll be talking a little bit about some of his experience from that today. So, Michael, what is your drinking word?
Voyager. Yes. Thank you, Erica. The outdoor recreation, I mean, now this is the time of year for that. I'm going to the river this weekend. I don't know about you, but it's too damn hot. Yes, so the summer school was such a great opportunity. I'll talk about it a little bit later in this talk, but I wanted to bring that up because that's why I'm talking about Triton. As many of you have heard over the years, I love Europa. I do a lot of Europa stuff, Jupiter system, so why am I talking about something else? It's because of this experience. And it's such an interesting moon. So hopefully we'll get to learn more about it tonight, and hopefully you'll be interested in it too and see why we must go back. All right. So a little introduction. It's Neptune's largest moon. All right. So we're all the way out in the Neptunian system. This is where Triton is. And you can see here on the right, this is the image of the one and only image we basically have of Triton from Voyager 2. And it was discovered all the way back in 1846 by William Lassell. It was just 17 days after the discovery of Neptune. So the Neptune was discovered, and, they had already discovered all the other planets and moons. So they're like, this one surely has moons. And they found one. And it's named after the Greek sea god for Triton, who is the son of Poseidon. And so this kind of follows that trend of generally the moons of the planets. So the planets have Roman names, but the moons generally have Greek names, with the exception of Uranus, which are like literature, Shakespeare, and I forgot the other author, but literature type names as well. Huh? Was it just Shakespeare? Pope? Oh, Pope. Yes, Pope. Shakespeare and Pope. Yes. And one of the most interesting things about this moon is that it orbits retrograde to Neptune, right? So Neptune orbits one way and Triton orbits the other way. And this is different because pretty much every other moon in the solar system, major moon at least, orbits with its host planet. So this was a fascinating discovery way back. So it was just a blip in the sky for years and years and years until the Voyager 2 mission, which was launched all the way back in August 20th of 1977, and it didn't fly by the Neptunian system until 1989. So even after it launched, there was still quite a long time before we actually got the first image at the system. And I hope you've all heard of Voyager before, but it was just an amazing spacecraft. There were two of them. The first one only saw Jupiter and Saturn, but the second one saw pretty much every outer planet. It was the grand tour of the solar system. We learned so much from these, and it allowed us to learn a lot about the outer planets and their moons. And that was enabled because it had 11 different instruments and systems on board. So this is, modern day, we would call this a flagship mission. This is like the cream of the crop. You send this out because you want to learn as much as you can. And then you have different cameras and you have particle instruments. So you're finding out lots of different things about the system that it's flying through. So you have Triton before the mission and Triton after Voyager 2, when we learned a lot about it. So one of the first things I'll point out is that, as you can see in the photo, it was seen in the lighting at the time of the flyby was the southern region. That's what you get when you get a flyby. You get a snippet of whatever it is, and it just happened to be the southern region. And what they found was a large polar cap in the south, as you can see outlined here. So that region is defined as the polar cap, and it expands pretty far. So that was noted as interesting. And then outside of that, they also found some interesting varied terrains that you really don't see on other icy bodies. This is an icy body, and one of these is what they call the cantaloupe regions, because if you look at it, it kind of looks like a cantaloupe up there. If you zoom in, it looks even more like a cantaloupe. Just want to reach out and eat it. Right. So interesting terrain features that we really haven't seen on other bodies. And then also hints of cryovolcanic features. As you can see in this image, these are those dark streaks. The question was whether they were active geysers that we're seeing like shadows or the materials, or whether we're seeing the fallout from it across the surface. Either way, this was a symbol, a sign of activity going on. And so the question was, are these active icy geysers? And then if these are, what could be causing them, right? And there's still some speculation about this, because with only one flyby, you really only have this image to tell you, okay, what's going on. So they've looked at it and given different aspects, such as Triton's distance from the sun and things like that. There's still questions about whether they are coming from an internal reservoir, or whether it's simply just, you could have a situation where you get little lakes that form, and then you get violent outgassing in one moment, and then that's it. So there's competing ideas. Remember I said we must go back? We must go back. We have to find out what's going on. So above the surface, it was also found that Triton has a very interesting atmosphere and ionosphere. And so an ionosphere is basically an area that's usually just above an atmosphere that's dominated by ionized particles. You have, whatever species is dominant in the atmosphere generally will have its ionized products in the ionosphere. We have one here at Earth. They exist at the other planets and even some of the other moons. So this is a common stratification of an atmosphere. But to dive into what we saw at Triton is that the atmosphere was primarily nitrogen. And this follows because the ice is primarily kind of a nitrogen icy surface. And that's what you expect kind of farther out in the solar system, that you're going to have a lot of nitrogen and species like that. But there were also smaller traces of carbon monoxide and methane present. Once again, this tracks well with what was seen in the Uranian system, Neptunian system, and even beyond that. So this is kind of what the outer system is abundant of. And then you can see in this image here, there's this little haze above the surface, which is thought to be clouds above the surface. So you have this stratification in this far away body. Like, this is such an interesting thing to find 30 AU away from the sun. But once again, one snapshot of this, and this is all we have to study at the current moment. Now, the ionosphere was found to be uniquely strong for this size of the body and the location of the body. And remember, I was talking about those ions. So you have the different instruments that can detect it between your plasma instruments that fly through and give you properties of ionized species and electron numbers, as well as radio science occultations. So if you point your radio dish towards the Earth, certain wobbles will tell you how much stuff is between you and the Earth as long as you're within the system. And as somebody that does optical occultations, these still confuse me. But it's a similar concept, but it's just instead of using light, you're using or visible light and ultraviolet light, you're using radio light, which is different, but gives you kind of similar results in the end of the day. So this ionosphere, the question is then, so we've determined that it is a strong one, but why, right? Is it solar radiation really impacting all the way out there? It could be. You could have a lot of photoreactions that are impacting the neutrals and creating these ionized species. Or perhaps the Neptunian magnetic system is active and interacting in a way with the moon of Triton that is driving the creation of this ionosphere, which would be interesting. And as we know from planets like Jupiter, where you have an active magnetospheric system that has a feedback with the moons, this is certainly a possibility. But once again, Voyager only has that one flyby, so we only have this one snippet. We can say that it's a strong ionosphere, but we don't know why. So that's another reason. And then because of this strong ionosphere, there was no concrete detection of an ocean, but there were wobbles in the signature from the magnetometer that said there could be an ocean. So this is how the ocean on Europa was detected. The Galileo flew by, the magnetometer saw certain wobbles that were like, okay, this has to be an electrically conducting liquid layer. At Triton, the issue is those wobbles could, as easily as they're caused by a liquid layer, they could be caused by the ionosphere. So because of only that one flyby, once again, there's no way to tease out that signal, and so there's inconclusivity about whether there should be an ocean under Triton. But people do believe that this is an ocean world, and if it is, it could be sustained by tidal heating. So as the moon orbits in a Neptune and is being stretched and compressed, that would be what would be driving the ocean to sustain itself, because you need heat to make sure that the liquid stays liquid, as opposed to radiogenic heating, which is basically, as radiation from internal components within the core of the moon that are decaying, and then as they decay, they release heat. That's how it occurs in most other places. But tidal heating would be very interesting if this was happening. The other unique thing is that they've found a 23-degree offset, so almost similar to Earth when you think about it, but it's really 157, but because it's orbiting retrograde, but that's 23 degree from the ecliptic or the equatorial region of Neptune. And that led people to believe that that Triton did not form with Neptune. No. It's likely a captured Kuiper belt object. So something sent it inward from out in the solar system, and then it got caught by Neptune's gravity, and it is now locked in forever, one of Neptune's moons. And combining the retrograde orbit with the tilts that we're seeing, it's a compelling case. And then the last thing that Voyager saw was got to keep you on your toes, was that Neptune itself had a wacky magnetic field that was tilted 47 degrees and offset, the center of the magnetic field offset half a radius from the core of the planet, which is just wild. But because of that, so as Neptune rotates and then as Triton orbits, you get all these weird things going on. It's going through different regimes of this magnetic field. The plasma sheet of Neptune you see here in one orientation, it's normal. This is a sign of what you see at Earth and other places. But in a different orientation, you could have, bifurcated plasma sheets near the lobes, which that's weird. That's just not something that you would see, that we've seen anywhere else in the solar system. So, these are things that would affect Triton and affect its ionosphere and atmosphere. But once again, we only have that one snapshot, so we don't know how it affects it. So hopefully, so far, I've convinced you that this is cool, but we have so many questions, so many questions. Now, since Voyager 2, there have been other observations of Triton, especially in the age of space telescopes. So we have Earth-based telescopes on the ground as well, but then you had Hubble and now JWST and other ones that were looking at it. And the talk about stellar occultations, my last AOT talk, or my first AOT talk actually, was about stellar occultations, which are great for detecting an atmosphere. Those have been used to further characterize Triton's atmosphere, and they found over time that the atmosphere grew in density, and independently in other observations, they found that Triton was heating up, most likely due to different seasons, right? So it goes through long seasons, right? Because it's 30 AU from the sun. So we have the snapshot from Voyager, but thank you. And somebody, but you know, from these other observations, we've been able to kind of keep in touch with it. And then most recently, we had the JWST NIRCam get this family photo of the Neptunian system, and look how bright Triton is. Just really fascinating. I mean, it's quite a large moon, but it's the beacon. Right? It's begging, it's calling for us to return. Kuiper Belt objects. I mentioned this is a Kuiper Belt object, and there's another Kuiper Belt object that was very, very unexplored for years and years and years until finally the New Horizons mission flew by Pluto in 2015. And studying Pluto was foundational because not only did it complete kind of looking at every planet in our solar system, and yes, I said planet, but you're characterizing these type of Kuiper Belt objects that are all the way, far away, and so by proxy, you're characterizing Triton in a way. You now have a comparison point for Triton that you never had before. So people went back after New Horizons on all the Pluto things and said, well, what do we know? Like, well, what looks same and what looks different between what we saw with Voyager with Triton and New Horizons with Pluto? So both have very hazy atmospheres that are primarily composed of nitrogen. They both have these complex icy surfaces with interesting terrains that really haven't been seen just within this, closer in the solar system. They both have similar sizes as far as radii. Those are the radii numbers. Sorry, I should have wrote that down. Triton technically does, though, have a denser atmosphere than Pluto. So Triton range, so when Voyager flew by, it was 1.4 pascals, and the maximum was 1.9 with the remote sensing from Earth. And then Pluto was only found to have 1. So this is part of that kind of intriguing thing that makes a big difference. And then Triton has the interaction with the magnetic field from Neptune that Pluto doesn't have. It's all alone out there. It's got Charon, but Pluto is the dominant body, whereas Triton is subject to Neptune system. And then they likely also have varied interiors. So if Pluto is also an ocean world, it would be a different ocean world than Triton in a different way. And this image here shows just specifics on what the competing theories are, but that's the gist of it is that they're not the same interior. So we want to go back. We've been wanting to go back for a while. There's been multiple missions that have been proposed to try to go back and see Triton in closer detail. And unfortunately, none of them have ever been selected. So for example, there was a proposal to have a New Horizons duplicate, a New Horizons 2 that would study these farther out objects, so trans-Neptunian objects. So those are objects around Neptune's, that orbit the sun around Neptune's orbit. And there was an idea that Triton should be included in that if that mission was going to go, but it didn't go. Then there was the Argo proposal, which was been a New Frontiers class mission. So New Frontiers is like a New Horizons mission that went to Pluto. that would fly by Triton and then continue out and go by the other KBOs, like what New Horizons did after Pluto went out to Arrokoth. There was the Triton Hopper, which would go to Triton, land, and then use the materials at Triton to fuel it to just hop around the surface. That one was very conceptual. It was interesting reading about that, but it made it through the first stage of development, but then it got axed. And then more recently, the Trident mission was a Discovery class mission, and Discovery, that's the class of like the Psyche mission that's going to the asteroid Psyche. And then this one lost to the two Venus missions that are now on hold, hopefully not for long, but that's the class of mission we're talking about. And this would have been another flyby like what Voyager did. Thank you. But, you know, with instruments that were meant to study Triton and a goal of answering a lot of those questions that we have. And then last but not least, the Neptune Odyssey mission was a flagship. So this is, you know, big, you know, Voyager-esque mission that would go to Neptune and then, you know, fly by Triton lots of times. As it studied Neptune, it would equally study Triton. But this one lost out to the Uranus orbiter in the decadal survey. Now, we don't have that going either, so, you know, we really don't have anything. But talk about that decadal survey. So the planetary science community, I mean, all the astronomy communities, but talking about planetary science, get together every decade and say, what do we want to do? What is interesting to us? Why do we want to do it? And Triton was included as a possible target for a New Frontiers class mission. And their concept study was the Triton Ocean World Surveyor. So that's what this is. That was like, okay, we can settle on this. Now, the main challenge of doing any mission to Triton is power. And to go that far in the solar system, you need radioisotope thermoelectric power. And that's limited. So that's right. I should have put the acronym. I know everything by, and NASA's everything is an acronym. So RTGs. And plutonium is how these things are powered. And plutonium right now is a little scarce. So getting these for spacecraft is difficult. We have some that are being used on the Dragonfly mission to Titan, and then beyond that, there's a big old question mark on when the next ones will be ready for whatever mission is selected. So this is a very competed thing, right? So if there is a mission to Uranus, it's going to need some too. So if you want to do Triton, you have to think of these things well in advance. You cannot stop thinking about this. And that is an actual issue that's going on right now at NASA, is they want to kind of say, oh, well, we'll think about it later. No, you can't think about it later, because you have to think about these things years in advance. And the other thing is a long cruise phase. It takes a while to get out to 30 AU. You know, you're just going to sit there and twiddle your thumbs. But, you know, you have to think about the logistics. Whatever team you have of people, you have to vary it from early career, mid-career, late career, right? Because perhaps somebody that was on the team when the mission gets going, and when it gets there, they're ready to retire. And what happens then? So there's a lot of different interesting logistics to think about when sending a mission. And that's why kind of it's been, the can has been kicked down the road, but eventually we need to do this because there's so many questions. All right. So the Planetary Science Summer School. This is hosted by JPL over in Pasadena, California, and it's a it's a 3-month course where students and postdocs get to learn from industry experts on how to build a NASA New Frontiers mission, right? New Frontiers, once again, New Horizons, Juno, OSIRIS-REx, those are all what we classify as New Frontiers missions. So they do very interesting things without being, you know, these big high-budget items, but they get the job done, and they get it done real well. And so this class, you attend virtually up until that final week, and then you go to JPL, and it's a lot of fun, and that's the photo of all of us there. And we chose Triton as our target. And so that's why I love Triton. doing that really, I learned so much about the moon, and I learned about why we need to go there and how we can go, how we can do it the best way possible with the best bang for your buck. And the final ideas are then presented to and critiqued by a series of NASA experts and judges, and it's just really, once you pass this, you are ready to do to go into mission work if that is your calling. And so we chose Triton as our target. Our name, we called it the Nautilus mission, and that's the pin I'm wearing right now. One of our team members made these for. We all met at a conference last year, and we got these pins, and it was really cool because even though this is a conceptual mission, it was very real for us, right? We spent 3 months of our life working on this, so this was a really foundational part for all of us. And when we set up our objectives, and you'll realize, hopefully recognize these themes from the talk, we wanted to study the ionosphere, we wanted to investigate the possible ocean. We wanted to characterize the core of Triton because that would affect, heating and other things for the ocean. We wanted to analyze all those varied surface features. And lastly, determine the cause of the plumes. And with the New Frontiers class mission, you can answer all of these questions. You can go there, you fly by a number of times, and you're going to learn a whole lot about this system and Triton. So hopefully I have convinced you that we need to go back to Triton, and that this is a really cool place, and it's really one of the more unique places in the solar system. It's difficult to go, right? It's far away, but technology is getting better, and I think we as humanity, we want to push farther, and we should push farther, and Triton's a great target. And learning about this and other Kuiper Belt objects really can teach us more about the origins of our own solar system, and how we came to be. And then it's at the intersect. Triton is at the intersect. It's an active body. It's got an ocean, potentially. And it's in a large magnetosphere that is very interesting. And these are all things that we as the planetary science community say are interesting places to study, because in an exoplanet, this is how you can have habitability. In the right place, if you have all these aspects together, you can have a habitable world. So kind of has the recipe for all that. So this photo is me at the Europa Clipper high bay back when it was before it launched in JPL. And my goal is that I can take this photo again someday in the future with that, and then instead of being Europa Clipper, it's a Triton Ocean World Surveyor. And now I'm realistic. I anticipate it's going to be a while. So, I'm going to have some gray hairs, but I really want this photo to come to fruition. So yeah, so that's Triton right there. That's my talk, and I'm going to talk a little bit now about me, because AOT, as you all know, you all have been around and part of my life for a while. So as Erica mentioned, I'm going to be leaving. So the future holds in store. I'm going to APL, Johns Hopkins APL in Maryland. Thank you. I'll be starting in October, so that means that September is going to be my last AOT with you all. So that'll be bittersweet, but I started coming to these all the way back when I started grad school. So this was September the 4th of 2019. Yeah. Dr. Fran Bagenal, who she's a great lady. She was a big part of the Voyager mission, and she was giving a talk about all of the targets of the mission, and there you go. Triton was one of them, and that's kind of serendipitous in a way, but that we're talking about this. But that was so cool to see. And then the other funny thing in this photo is there's me, the side of my head. So from then to now, it's been an amazing experience to be up here, to not only give multiple talks to you all, but just to facilitate this event, to bring astronomy to you. This was the video. This was the video we did to celebrate Voyager. We did. There was a what was it? The anniversary, right? Something like that. I think so. Yes, and then there's all of us there. I mean, yeah. What a time it's been. I'm really grateful that I had this experience. This is an extended family to me. I'm going to miss it, but I'm excited for what's coming next, and I know that I will be back someday. San Antonio's, after 7 years, this is a second home to me. So I'll come back, hopefully give some talks, and see you soon.
Thank you, Dr. Michael Velez. That was a great talk. When are you going to come back?
Well, Erica's going to be defending her PhD in the spring, right? So I'd like to be back for that. So definitely.
Have some opportunities. Next question. Why haven't we gone back?
Well, I think part of it was what I was saying, that the limitation. So for a while, the limitation really was the nuclear power for the radio thermal generators. There just wasn't the capability to build these. So Cassini went in 04? No, it got there in 04, but it launched before. So Cassini had the generators. New Horizons had generators, and then there was a big old dearth of missions with generators up until I guess Dragonfly, if I remember correctly. Yeah. So and Dragonfly hasn't launched yet. New Horizons launched in 06. So we went all these years because there was a lapse. They did not enrich and develop the plutonium that was needed for these generators, and so you had to throw away any of the missions that required them. Just got thrown away, and that's part of the reason why Triton or any other outer solar system target beyond Jupiter wasn't on the docket for so long. Because Jupiter, you can still have solar panels like Europa Clipper's basketball court-sized solar panels. You can get away with that at Jupiter. You can't get away with that much farther.
I will double down on going back to Triton. As you said, it's potentially a captured Kuiper Belt object. I never realized it's about the same size as Pluto. We could learn a lot about the Kuiper Belt and about capture just going to visit. That's an insane system, as I realized in your talk. How long would it take to get to Neptune, do you think, off the top of your head? P squared equals A cubed, do that math. If you're flying about, I don't know, take your rocket velocity as you're going up.
As is always the case with planetary exploration, it depends. What gravity assist do you get? So Voyager, when 1 and 2 were going, it was one of the most perfect orientations you'll ever get to do what it did and see pretty much all those planets. Other times it's not so kind, right? And they found that you can launch a mission directly to Neptune, and it's going to take forever, but you can technically do it, and it's going to take probably 15 plus years. But if you want to cut that down and get it even under 10, you need Jupiter. So sometimes you don't need Jupiter, and sometimes you do need Jupiter, depending on orientation. So it varies. At best, you're going to get there less than 10 years. So a New Horizons, think about it, went from 06 to 15 to Pluto. 9 years. Record time. Oh, yeah. 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 Not Juice. Juice is longer than Clipper. But yeah, I don't know. Yeah. But so it varies, but you can get there quicker. But the issue is, and they're exploring this with Uranus as well, is What if you go there really fast and then use the atmosphere of the planet to brake? Process called aerobraking. They're studying it because, yeah, you'd get there really quick, but then you'd have to really slow down because it's the logistics. If you want to stay in the system, it's easier to fly by because all you have to do is zoom, fly by, and you're done. But if you want to stay in the system, you have to slow down because if not, you're going to swing and then get shot off somewhere else. So what are the goals of your mission, and what planet orientation is going to depend or determine how long that cruise phase takes.
Why are the magnetic field wobbles of the ionosphere and hypothetical ocean indistinguishable?
The particles, the plasma particles are perturbing the magnetic field. And then what the perturbation you would get from the conducting layer under the surface is going to be roughly in that same region. And so with, what you have to do is you have to have a strong plasma sensor so that you say, here was the plasma condition as we flew by, and then that's the signal you subtract, so that you're subtracting the ionosphere and the other plasma, and then what's left over is anything beneath you, and that's how you can characterize that you found an ocean. So that's the problem. With just one thing, with just the magnetometer, you have questions because the signal is basically going to read the same either way. They're both going to cause roughly the same perturbation. But if we have an in situ instrument that can help us subtract the signal, okay, now then you can learn about it.
And lastly, what are you going to be doing at APL? And are you going to be doing an AOT over in Maryland, in Baltimore?
I'll look into it. I don't know if Baltimore has one. I know DC has one. Yeah. 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 Yeah, that's the advantage of having students as a part of this, is that we, if you've been coming here for years, you've noticed that the amount of time you've seen Tracy has been negative slope. And for good reason, right? She's moving up in the world. So exactly. Her work is a positive slope. Her time for AOT is negative. But thankfully we have the students here to do that. So, but I definitely, AOT will look into presenting at those DC and or Baltimore, because I really enjoy it. And hell, if they have room for involvement, maybe I'll, weasel my way onto those teams. What was the other part? What am I doing? Oh, okay. So space telescopes. We have Roman about to go up. What's next after Roman? The Habitable Worlds Observatory. And I'm going to be helping out with kind of defining what do we want out of the Habitable Worlds Observatory from a solar system lens, especially for icy ocean worlds, like Triton, by the way, for investigating these, because, these astronomical telescopes, yes, they get these beautiful images of faraway stars, but they also get beautiful images of our own backyard. And so, I still think we need to go to Triton, but a mission, or the Habitable Worlds Observatory, will get you much better images of Triton than we've ever had from Earth. So I'm excited about things like that. And then Enceladus, which is also a icy moon that has these huge geysers. Huge. If you've never seen the Cassini images, look at those. They're incredible. But I might do some James Webb research on Enceladus as well. So, staying in the icy moon world.
With that, let's thank Dr. Michael Velez one last time. There were a couple questions that were unasked. I think Michael's going to be here for a bit. We got to do trivia. But Michael, if you could do the conclusion for the night. I have a case of the planetary science summer schools.
Oh, okay. Yes. So
gotten it.
Hello. We're going to get started in a moment.
I'm assuming we're not running.
With the amount of people in here, everybody will win something, surely, right? No. Y'all split into 2 teams? Oh,
We'll allow it one time.
we'll allow it. That's clever. So I'll allow it because it's clever. But as half FTEs, if you're going to do it the right way, that means you can only help with 3 questions. Right? Yeah. So. All right. Funded time.
Hold on, I'm first. All right. Everybody who's playing has a sheet.
Yeah. That's a lot of Earths. The sun is truly that big. And the sun, I mean, when you think about it, the sun is like middle ground of star size. So, yeah. So those giant stars are like, wow.
They're suns and suns.
Exactly. Yeah.
Question 5. Finish that lyric. It was A. Hey, it seems like years since it's been clear. Oh. I can't hear the song in my head, so I can hear the song, I just can't hear that specific lyric. I can hear the not the chorus, is it the chorus? The part that repeats? Yes.
All right. Celebrating our 250 years, we're sending a message to Triton, and we're telling Triton, hey, we're having fun. We're having an anniversary. 250. How long would it take for them to thank us from when we sent it? See, 8 hours and 15 minutes.
How do you do that math? Yes, on average. Because how do you do the math? Well, yeah. So Earth is 8 light minutes away from the sun. And then at 1 AU, that's 1 AU. Neptune is roughly 30 AU on average. So 8 times 30 is 240 minutes. That's 4 hours. But it's both ways, so there and back. That's about 8 hours. And so, yeah.
Yes, but this is Earth to Neptune right now, right? That's what I did, was look at the eyes of the solar system to be perfectly accurate about what it would. The question. Listen, hold on, folks. The question is, you're barbecuing on Saturday. If I do average, that's not the time on Saturday. Okay. You got. Yeah. And you got close enough. Yeah, there you go. Good job. All right, bonus.
You learned something in Kurt's class. Bonus. In the bonus section, what was the bonus? Oh, order the outer planets, not Pluto, outer gas giants by the number of moons. Who has the most moons? Saturn, 293. And then Jupiter, and then Uranus and then Neptune. I want to say it was within the last year, there was like a 40 or 50 count drop on the Minor Planet Center, which is like what astronomers use for like keeping up with stuff, like orbits and stuff. But like someone was just like, hey, there's a bunch of moons around Saturn, here they are. And it was just like 50 of them. It was crazy.
Wait, was this what? Was that you or somebody else? If for those AOT regulars, no. Okay. But point is, one of those Uranian moons, we had the founder, or like the person who found one of those moons, discoverer, thank you, speak at AOT. Fun fact. That was a lot of fun. So, yeah. I think it was at 28, and then she found the 29th moon. I have no doubt that Uranus and Neptune have far more moons than that, but it's what we can see. And that's why on this one, I remember to put so far. Once we have, I don't know how much Roman will help, but habitable worlds will definitely help find more moons of the solar system objects, as well as all of these other ground-based telescopes that are getting better. You just have to point at the system and look for them.
Prizes. What's third? Third is stickies, SWIP stickers. Oh, every winner. Wait, every person or every group? Okay, every person is going to get our AOT stickers. Inaugural night. We're gonna ask AJ to print more. We got him on deck from Sweary, so. Number third is Celestron. Come on, Mark. Mark, Celestron, Jurina. At least you have 2 new ones. Minimum 2. Second place, winning Blue Star branded growler. They're not growlers. They're steel cups, mugs. The what? The tasty gravity waves. You can fight over the cups. You can fight over the pints. 1, 2, 3, 4, 5, 6. 6 more. However, or depending on how many you put in there.
No. Or no.
Shut up. I can do math. Let me do it.
No, I was. Okay, that's not what I wanted. But we can ask him to come.
Yeah. First, the first place is Texicans. Got some moon prints. And all the information about the moon prints are on the bottom of the print, and then you also get some AOT stickers.
Congratulations. All right, once again, I said it before, I'll say it again. We're coming back August 5th. Click one more, Aaron. We're coming back August 5th, and this dapper fellow will be giving a talk, so don't miss it. I should say dapper doctor. Dapper doctor. All right, good night, everyone. Thank you for coming.